Hello students, this is another lecture of vectors. In this lecture, we are going to learn the concept of section formula. We are going to learn the concept of section formula. Now in section formula, we have two types of section formula, which is internal division section formula and external division section formula. So we will have these two formulae. After section formula, the next one we will have a formula based on section formula, which is midpoint formula. We will have midpoint formula. After midpoint formula, we will go for centroid of a triangle formula. That is formula for centroid of a triangle. Centroid of a triangle. Then we will have a formula for centroid of a tetrahedron. So what is a tetrahedron? That we will know when we will go for centroid of a tetrahedron formula. We will have a formula for centroid of a tetrahedron. So we have got these four formulae to be done in this video. So I will teach you this part in much detail. So let's come back to section formula. Now, so for a section formula is concerned, there are students who do this formula in 10th grade, that is in 10th standard. Okay, so we are going to first have a revision of what we have done. So we will have a revision of what we have done in 10th standard about section formula. Now, what is important there is that when we do this formula in 10th standard, we do it in XY plane, that is 2D plane. We do this in 2D plane, that is we have coordinate system, that is x-axis and y-axis. We have x-axis and y-axis. So once I have x-axis, y-axis, what I now call this as, this which we call is, this is known as the, this is the plane of paper, plane of paper, plane of board, plane of screen, plane of your mobile phone screen, whatever. This is plane. It's a plane. Okay, it is XY plane. You understand? This is a two-dimensional thing. So if I have a segment, I will have a segment in this plane. You see this? It is plane. This is in two-dimensional plane. Okay, you are drawing it on a plane of a paper. You are drawing it on a plane of a paper. So see, this is 2D plane. But so this thing we have done section formula, but we have done it for 2D plane. But here what is going to happen? We are going to see the section formula in 3D space. Okay, so how does that happen and all? We will see. It's a matter of concept which will come in a short while. So before we go for that, let us have a revision of what we have done in 10th standard. Okay, so let's do it. Let's begin. So we will start with the revision part. So section, here I write revision. I write here a revision of section formula. Revision of section formula. So let's begin with it. So in 2D plane, in 2D plane, suppose you have one segment, you have a line here, right? You have a line, and on this line you have 2 points. You have a point A and you have a point B. So A and B, you have 2 points on the line. Now there is another point which is C, and that point happens to be in between A and B. The point C is in between A and B. Okay. See, the things that we are going to do here, you will notice that when we this thing, I'm calling it as a revision, but you will notice that when we will go for the section formula in 3D space, three-dimensional space, then you will notice that much of the things are same. Much of the things are same. The only difference will be in 2D plane, a point has only x and y coordinates. If you have 2D plane, so suppose if I call this as 2D plane, it means I will definitely be having somewhere y-axis and x-axis. So if I have y-axis and x-axis, then each point will have x and y coordinates. So for that matter, the x coordinate of point A will be this displacement. You see this? This is x coordinate. This is x coordinate, and y coordinate of point will be this displacement. This is y coordinate displacement. So see, now there is some, the x of this will be negative. X will be negative because it is on the left. This is y-axis, this is x-axis. The x coordinate of A will be negative, some negative number, say -8 you have, and the y will be positive. Okay, say it is 4. Same way, B will have x and y, C will have x and y. So what I'm trying to say is, if in this 2D system, when you are learning section formula, it's going to be very much similar to what you will learn in 3D. So this revision is very important. This is very significant. So because when I revise this, much of the things you will find that you are going to have same. But in 2D system, the points have only x and y coordinate. When we will apply this to 3D system, then the points will have x, y, and z coordinates. Now, how is that happening? You know it. I have already explained this in earlier videos, so you can check that video. So here we are starting with, it is 2D system. So here we have point C. So point C is in between AB, and these 3 points are collinear. Now since point C is in between AB, we will write here, we will write a statement. Remember, the diagram is important, the statement is important, everything is very important. So I will write here, point C divides segment AB internally in the ratio. See, this ratio which I'm going to write, it is decided by the fact what is happening. It is decided by the fact what is happening. So here you are writing C divides AB. You are writing C divides AB. So if C is dividing AB, then the ratio will be AC upon BC. What will be the ratio? AC upon BC. Remember that. This will be the ratio. Now for your understanding, suppose if somebody writes, for the same diagram, if somebody writes point C divides segment BA. Why not? If C is in between AB, you say C dividing AB. So why can't you say C dividing BA? You can definitely say. So if somebody says point C divides segment BA internally in the ratio, then what would the ratio be? See, the order in which you write is important. So here you are saying C is dividing segment BA. What are you saying? You are saying C is dividing BA. So in that case, the ratio will be BC upon AC. What will be the ratio? The ratio will be BC upon AC. You can check what difference now you have here when you are saying BA instead of AB. So C dividing AB, understand, C dividing AB, the ratio, and C dividing BA, the ratio, they are reciprocal of each other. They are reciprocal of each other. So this thing you have to understand how is this being written. So I will suggest you draw the diagram and write these two statements. These are very, very, very important concept. You can pause the video and write the statement. Now let's go ahead. Students, suppose now I will take the discussion ahead. See, suppose here I have the distance between A and C as 30. I have distance between A and C as 30. This is 30 units. Okay, this is 30 units. This distance is 30 units. And distance between B and C is, say, distance between B and C is 10 units. This distance happens to be 10 units. So if it is this way, what will I write? Now, when this is 10, needless to say that this will become 20. This will be 20. Okay. This will be 20. Now, see what will happen. This statement, okay, let me now remove this, because this one, the second one I had written only for the sake of making it more clear. So since you all have understood, we will have to go for any one of these two. Okay, for taking the discussion ahead, we need to go for any one of the two. We don't have to write both. So I will go for the first one. So let me remove the second. Okay, now see. So point C divides segment AB internally in the ratio AC upon BC. What is AC? 20, and what is BC? 10. So the ratio will become 20 upon 10, 20 upon 10, that is 2 upon 1. What is the ratio? 2 upon 1, which is nothing but 2 is to 1. What is it? It is 2 is to 1. It is 2 is to 1. 2 is to 1. Okay, now what does that mean? What does that mean? Listen. Now I will write the statement once again, and this time see how I am writing. I will write point C divides segment AB internally in the ratio 2 is to 1. What I wrote? I wrote point C divides segment AB internally in the ratio 2 is to 1. It clearly indicates, see, I may not be having the actual length. Okay, see here what I have is distance between C and B. I'm sorry, I have distance between A and C and distance between C and B. Here I have the actual length. But when I'm given such a statement, I may not be having the actual length. But what I know is that C is dividing AB in the ratio 2 is to 1. That means C to A is 2 times of C to B. This is what I know. This is 2, this is 1. So if this is 10, this would be 5. If this is 10, then this would be 5. What I know is if this is 14, then this would be 7. If this is 20, then this is 10. And if this is 30, then this one is 15. That is what I understand from this statement. Okay, and that is what the idea of ratio is. We are only getting the ratio, that is AC upon BC. This ratio doesn't give you the actual length. Okay. Now there is one more thing which can be incorporated with this concept. When I say C divides AB internally in the ratio 2:1, it can also be understood as if there would be total 3 segments. See, 2:1. So there would be total 3 sections. I'm sorry, sections. I can also understand that there would be total 3 segments, and those 3 segments would go as follows. See, B to C is one segment, B to C is one segment, and C to A to C will be 2 more segments. Okay, so there will be total 3 segments. I'm sorry, sections. I'm extremely sorry. Once again, I said segments. So this 2:1 would also mean that there will be total 3 sections of AB. There would be total 3 equal sections of AB. There would be total 3 equal sections of AB, of which A to C is 2 sections and B to C is 1 section. That is why it is 2:1. So this is the concept. If I'm given that I go for the next one. Suppose here I'm given point P divides segment MN internally, segment MN internally in the ratio 3:4. Now what does that mean? That would mean as follows. See, it means that we will have MN, okay, and P is dividing MN. So see here, P divides MN. That means the ratio is MP upon NP, MP upon NP, which is 3/4. So MP is 3 sections and NP is 4 sections. So it would mean something like this. See, here is P, this is 3 sections, and from here to here is 4 sections. So this would mean that there will be total 7, equal sections of this. There would be total 7 equal sections of this, of which there will be total 7 sections. You can count 1, 1, 1, 1, 1, 1, 1. See why I'm writing 1? Because each one of them is 1. So that's why, 1 plus 1 plus 1 plus 1 is 4. And here 1 plus 1 plus 1 is 3. You understand? So this is also one of the concepts. I hope you all have followed it. This is the internal division section formula for 2D, which we have done in school. Okay. Now see this. So here now I will draw another diagram, and this time I will write the statement as follows. As I have written 2:3. Now let me make it more general. Make it more general. So I will write this in general. So see, how do I write? The statement which now I write would be, see, I will write here point C divides segment AB internally in the ratio m:n. Okay, so this is m:n, which I wrote 2:1 is m:n. So what does that actually mean? See, I'm saying C is dividing AB. This is very important. Every time I'm showing it to you so that you understand. So AC upon BC is M upon A. So if AC upon BC, if AC upon BC is M upon N, it means here I would write this, I would write M, this is M, and this is N. You understand? AC upon M upon N I have. Okay. So the question from your side could be that why are we doing all this? Why? See, it is because if you know the coordinates of point A, suppose you know the coordinates of point A as x1, y1, you know the coordinates of B as x2, y2, and you know the ratio of division, okay, we could find out the coordinates of point of division. The point which is dividing the segment, its coordinate could be found. So let me write the coordinates of C as h comma k. I do not know the coordinates of C, so I write that as h comma k. So what I repeat it once again. When I know the coordinates of A and B, and I know the ratio in which this point C is dividing segment AB, that is M is to N, I can find out the coordinates of point C. I can find out the coordinates of point C, and this will be as follows. See, H equals to, what is H equals to? H equals to, you will have here, H equals to mx2. What will be, H? It will be mx2, m will multiply x2, the x coordinate of point B, then nx1 plus nx1 plus nx1 upon m plus n, upon m plus n. What you need to follow here is that when you are writing the x coordinate of point A, point C, when you are writing the x coordinate of point C, you are using only the x coordinate in the formula. Okay, mx2 plus nx1 upon m plus n. See, there is a derivation. That derivation right now we are not taking because we are taking the formula directly. I will show you one trick for remembering this. See, m multiplies x2. How will you remember this? See, for remembering this, I tell you a trick. The trick is C is the main point here because C is the point which is dividing the segment AB. So C and A, C and B, C, A, C, B. C is the main point, right? The number between CA will multiply the coordinates of B. The number between CB multiply the coordinates of A. See, this is the simplest trick that you have. Okay, I hope you follow. Now I will write the y coordinate of C. So C, k equals to, okay, I write the y coordinate and k equals to, once again, m multiplies y2, my2 plus ny1 upon m plus n, upon m plus n, my2 plus ny1 upon m plus n. Okay, so this we have done the revision of section formula internal division, what we have studied in 10th grade, right? It is revision of section formula internal division. Now I shall revise the section formula external division, and then we will move to our portion in vectors. Remember, if you have known this part, then when we go to 3D space, you will notice that you hardly have to study anything, okay, because more than 90% of things will remain the same. So it is very important that you know this. See, I specially revised this because most of the students have forgotten what they studied in school, or if they have learned it, they still do not know it very well. So I have revised this. I want that you copy this and also learn it well. Now we will go for external division section formula. So now we are having revision of section formula external division. Once again, we will start with a line. This is line, and On this line I have 2 points A and B. I have a point A, I have a point B. Now there is a point C, and this point C divides segment AB externally. Now what does that mean? It means that point C does lie on the same line. Point C does lie on the same line, but it is not in between AB. It is outside AB. It is beyond AB. So here we have point C, and point C is not in between AB. Remember, for internal division, where was the point C? For internal division, see, this is A, this is B, and C was in between AB. You see this? But now where is point C? Point C is outside AB. It is this. Here is point C. Okay, if few of you are thinking that why can't point C be here? Why can't point C be here? Yes, that is also a case. Point C can also be here. But when point C is here, this will all be clear within a short while. Okay. So, but one thing is sure, that if it is external division, then point C is not in between AB. So here I take point C, and point C is outside AB. So I will now write a statement. Okay, let us write a statement. What will the statement be? The statement will be point C divides segment AB, externally. One more thing I would like to say here, that many students, they take the term divides literally. Okay, this is just a mathematical concept. They take the term divides literally. What they say is, if C is not in between AB, then how could it divide? And then they are always in trouble, because they take the term literally. Remember, this divides does not mean cutting. Okay, we are not cutting it. Okay, so please, it is just a mathematical concept, and this mathematical concept is very significant because it helps us understand a lot of other concepts. So please do not take the word divide by actual dividing. Okay, that uh, we divided a stick into 2 or 3 sections by cutting it. That is not divide. This is a mathematical word here. It has mathematical sense. So point C divides segment AB. Here what I would say point C divides segment AB, and then I would say externally in the ratio. Now how would I write the ratio? See, for writing the ratio, whatever I had taught for internal division, same thing is applicable here. So C is dividing. What is it dividing? It is dividing segment AB. C is dividing segment AB. So the ratio will be AC upon BC. What will be the ratio? The ratio is AC upon BC. We can write AC upon BC as the ratio. So the ratio this time is AC, you check this, AC upon BC. Okay, that you need to understand. AC upon BC is the ratio. AC upon BC is the ratio. Okay, and the same thing which we wrote here, the diagram looks like this. And internal division, you see how the diagram looked like. The diagram looked like this. You know, C is dividing AB in the ratio m is to n or 2 is to 1, whatever. AC, okay, the diagram looked this way. How did it look? It was, see, AC is to BC. You see this? AC is to BC. Where AC ends, BC starts from there. You check this. Where AC ends, BC starts from there. but that is not the case here. What is the case here? Here, BC is within AC. BC is within AC. C is dividing externally. So these are the small changes that you need to understand. So here we have point C is dividing segment AB externally in the ratio M is to, in the ratio AC is to BC. Okay, so if I have this distance as, suppose AC, distance AC is, suppose distance AC is, say, AC is 40. Distance AC is 40. This time I'm writing actual distance, okay, units. And here I have, say, this distance I have BC, I have is, say, 15. BC is 15 units. Okay, so what is this? This becomes 25. This will become 25. Now, so what will be the ratio? As you know, the ratio of division is, AC upon BC. So AC upon BC, that is 40 upon 15. Okay, so here I shall now write the new statement as point C divides segment AB externally in the ratio 25 upon, it is 40 AC upon BC. Okay, not 25. AC upon BC. What is AC? AC is 40. So 40 upon BC is 15. So 5 threes are and 5 eights are 40. So how much is this? This is 8 is to 3. The ratio is 8 is to 3. You can check. You can now check here. From this to this is 8. This is 8. And this here is 3. You see this? This is 3. So 8 is to 3. So point C divides segment AB externally in the ratio 8 is to 3. Point C divides segment AB externally in the ratio 8 is to 3. So here now I understand here. If you remember in the beginning, I had told you that when C is dividing AB externally, then why write C that side? Why not this side? Now I will make you understand that part. I hope you all are understanding up to this. So I shall now make you understand the next. See, when you wrote that C divides segment AB externally in the ratio 8 is to 3, you know it is AC upon BC, which is 8 upon 3. So A to C is 8 and B to C is 3. So start thinking that if you have a segment, let's have a segment, okay? Look at this diagram. And on this, if I have A here and B here, A and B here, A to C is more than B to C. You see this? A to C is 8. Try understanding. A to C is 8, B to C is 3. So where should that C be? If I have C here, then A to C is less and B to C becomes more. How could I be writing 3 this and this as 8? I hope it is understood. Okay, how could I write C here. C cannot be here if it is AC upon BC 8 upon 3. So where should C be? C should be here. C should be here. Now I can say this is AC is bigger and BC is smaller. So this is 8 and this is 3. 8 is to 3. I hope I made this clear. I hope I made this part clear. So when you read the ratio and you read the statement, you can decide which side the point of division would be. Which side the point of division would be. Okay. So one more thing I would like to take here is, in case if I had written, okay, in case if I had written the statement the other way, suppose if I had written point C divides segment BA, if I had written it this way, segment BA externally in the ratio, then what would I be writing? Since I'm writing C divides BA, if I'm writing C divides BA, it is BC upon AC. So BC upon AC would be 3:8. I hope it's clear. It is 3:8 in the ratio 3:8. Okay. Now start working on this diagram. Once again, suppose I had the statement this way, point C divides segment BA externally in the ratio 3:8. So you have a segment, okay, and then you have here whichever way you want, you can have here, A or B, whatever. If you're taking A here, then definitely you'll take B here. Now you are saying that segment C is dividing segment BA in the ratio 3:8. So C to B is 3 and C to A is 8. C divides BA in the ratio 3:8. So C to B is 3, C to A is 8. So if C to B is 3, C to B is smaller than C to A. So definitely C has to be here. You understand? So this is smaller and this is bigger. So students, in the different various ways, I have explained you this part. I hope this is clear to you. We can now write the formula for external division. We can write the formula for external division. So what I will now do is I shall go for a diagram with the general statement, that is a ratio will take as, in general, we will not take it as in specific. We will take ratio m:n. So here I have a point A here and a point B here. Okay, and the point of division is C. So I know the coordinates of A. The coordinates of A are x1, y1. Coordinates of B are x2, y2. And coordinates of C are h comma k, okay, which are unknown coordinates. I know the ratio of division. The ratio of division is m:n. So here I write the statement first. I write here point C divides segment AB externally in the ratio m:n. Now you all know if C is dividing AB in the ratio m:n, that is externally, C to A is M, C to A is M, and so this is M sections, and C to B is N. Okay, see the difference of the diagram for internal and external division. Okay, this is N. Fine, C. So now we can write the coordinates of C. See what will be the coordinates of C. C will be mx mx2, mx2. The idea is once again same. See, which is the main point here? Remember, always the point which is dividing is the main point. The point which is dividing is the main point. So the formula is written for the main point. The formula is written for, always written for the coordinates of the point which is dividing. The point of division is C. So I will write the formula for H and K. So H equals to, now see, in between C and A, C is dividing AB. C is dividing AB. So A, C and C. C is dividing AB. So C, A, C, B. So the number between C and A will multiply to coordinates of B. So mx2 minus nx1. Remember, here it is minus. It is not plus. It is external division, so it is minus. mx2 minus nx1 upon m minus n. Upon m minus n. This is the x coordinate of point C. Now we will write the y coordinate of point C. And here k equals to, and k equals to my2 minus ny1 upon m minus n, upon m minus n. We have done the revision part of what we had studied in school. I have revised this in much detail. I would suggest you do this very well, so that when we go for the next, that is that is section formula, internal division and external division in space, that is for vectors in 3D space, you will find it very easy. So we have done the revision for section formula internal division. We have done the revision for section formula external division. And this was all in 2D plane. This was all in 2D plane. Now we are going to extend this concept to the 3D space. Okay, that is, we will apply this concept to vectors. Now listen students, everything that I will do, you will notice that I do it in these diagrams only, and with these things only. Everything I will do in this only, so that you will find it much easier. There are some changes which will happen, and those changes I will show to you, making them in these diagrams itself. So let me now begin with, so here I go for, let me remove this revision part, because now this is no more revision. We are going to see it for the first time, that is C. Okay, that is for the vectors. Here I wrote point C, C. Okay, now this formula won't be there now. Okay, now see. First of all, I will draw the diagram. So let me draw a diagram. Let this diagram be here. Let this diagram be here, because I want you all to, the new diagram which I am drawing, I will make you understand with the help of what you have earlier done. So here I have a segment. I have a segment AB. I have a line here. I have a line here. Now on this line, I have 2 points A and B. I have 2 points A and B. Okay. I write the heading. What is the heading? Heading is internal division section formula. Internal division section formula. Okay. So here I have 2 points A and B. I have point A and point B. The coordinates of A are, what are the coordinates of A? Tell me, what were the coordinates of A here? It was x1, y1. What will be the coordinates of A here? It will be x1, y1, z1. Remember, why? Because this line is in space. It is not in plane. It is in space. It's in space. Okay. And then it is like, I can make you understand. It is like a big stick. Okay, a bamboo stick you are holding in your hand. So if you are holding a big stick in your hand, what is it? It is a straight line in space. So it is kind of that, it is space. And then you are maneuvering that bamboo stick. You are rotating in your hand. Okay. So this is a line in space. So then you have A as coordinates of A as x1, y1, z1. The coordinates of B are x2, y2, z2. Okay, x2, y2, z2. And now there is a point C which divides segment AB. C is dividing segment AB internally. Okay. What what are the coordinates of C? They are unknown. And as these 2 points have x1, y1, z1, x2, y2, z2, they have 3 coordinates. The unknown coordinates are x, y, and z. These are unknown coordinates. Okay. And the ratio of division is same, m is to n. Okay. So here I have m, this is m, and here I have n, this is n. AC upon BC is m upon n. AC upon BC is m upon n. Okay. What now I have to do is I have to write the I have to derive the formula for this. Okay. So you can now compare once again. I will make you compare this. See, A was here you have in 2D plane. This is in 2D plane. There is no x, z coordinate. So x and y coordinate for A, x and y coordinate for B, x and y coordinate for C. The ratio of division is m is to n because uh, point C lies in between AB. Here also point C lies in between AB. Okay. So now it is time to remove this. You have understood the changes that we have. Okay. See here. As you know, students, that these points are in space, and these points, if I join them with the origin, somewhere I will definitely have the origin. Say the origin is here. This is the origin. Okay, O. Okay, in 3D space, you have X, Y, and Z axis, and these 3 axes where they are mutually perpendicular, that point is the origin. So now what I do is I join this O with A. Now when I join O with A, what I get is the position of point A. I get position of point A with respect to O. What am I getting? I'm getting position of point A with respect to O. I'm getting its direction, I'm getting its distance, everything with respect to O. So this gets me the position vector of point A, which is A bar, Okay, so this vector is A bar. Similarly, I have another vector which is B bar. See, this vector is B bar. It gives me the position of point B with respect to O. This is B bar. Okay, and here I have the vector C bar, position of point C with respect to O. This is vector C bar. Okay. Now the idea here is if I know, try understanding this. The idea in vectors is extended. Try to understand. In 2D system, when you did the same internal division section formula, everything was for finding the coordinates of point of division. What happened there? You knew the coordinates of A, you knew the coordinates of B, and you found the coordinates of C. And here what is happening, you will definitely find the coordinates of C, but other than that, you will also find the position vector. You will also find the position vector. It means that you will express the position vector of point C with in terms of position vector of A and B. I repeat again. In when you are applying the section formula in 3D space, that is in vectors, here we take the concept one step ahead. That is, we will definitely find the coordinates of point C, that is point of division. We shall also find out the position vector of C, that is C bar, in terms of A bar and B bar. We will do that also. Okay. So here I first of all I make a statement here. So see, the statement goes as follows. I write point C divides segment AB internally in the ratio m is to n. M is to n. Okay. So prove that, let us make this a question. Prove that C bar equals to, what is C bar? C bar is the position vector of point C. Prove that C bar equals to M B bar plus N A bar upon M plus N. Prove that C bar is equal to MB bar plus NA bar upon M plus N. MB bar plus NA bar upon M plus N. We will prove this. So this is the statement of the theorem. You can say we are going to prove this. So the proof will start from here. We will start writing the proof. I will write given point C divides segment AB internally in the ratio m is to n, in the ratio m is to n. Okay, so therefore we can write, see what we can write. Which point is the point of division? C. It is C which is dividing. And what segment is it dividing? It is dividing AB. So C is dividing AB. So what will be the ratio? The ratio will be AC upon BC. The ratio will be AC upon BC or CA upon CB. Whatever you write, that doesn't matter. Okay. So here I write AC. Therefore, we can write AC upon BC is equal to M upon N. See, AC upon BC is equal to M upon N. Remember, I could have even written AC upon BC. I could have even written CA upon BC. CA upon BC or as M upon N. That hardly matters. That is okay. The only thing is, if you have C dividing AB, then this should come first. Now, it should come in numerator. So now it is coming in numerator as AC or CA, that hardly matters because what we are right now dealing with is numbers. Okay, next. Now I cross multiply. Therefore, NAC equals to MBC. NAC equals to MBC. I will write NAC equals to MBC. Okay. So till now it is all okay. Now see the next part. The next is the important step. The next is the important step. Now why it is important? You will note it now. See, I'm writing n, and this AC, I would convert it into a vector. So AC bar, what I wrote n into, n is a number, and AC here was definitely a number. AC here is a number because this AC is the distance between A and C. So that is a number. But here I made that AC a vector from A to C. What I did, I made AC a vector from A to C. So if I'm making a vector from A to C, look at the direction. The direction is this. This is AC bar. You see this? This is AC bar. And then this is AC bar. Look at the direction. And here I have M, BC. I make this as a vector, BC bar. So if I make it as a vector, look at the direction. BC bar. You see this? BC bar is this vector. BC bar is this vector. This way. This is the direction. This is BC bar. The direction is this way. You see this? But here it is only this much. BC bar is this vector. The direction is this way. The direction of AC bar and BC bar are opposite. So now what will happen? You cannot write equal to sign here. You cannot write equal to sign. Why? Because now each of the side, this side and this side, they both have become vectors. They both have become vectors. So if you are writing an equal to sign, you will have to put a minus here. Why minus? Because they have opposite directions. Their directions are opposite. So I will write a negative sign and then I write equal to. I write negative sign and equal to. I hope you followed it. Okay. Now we move to the next part. See what is the next part. The next part here is, you know, AC bar is a displacement vector. So it would now be, next step, n C bar minus A bar equals to minus M C bar minus B bar. Then I will multiply n inside. So NC bar minus NA bar equals to minus MC bar plus MB bar. Then I shift this MC bar on the left. I shift this MC bar on the left. So I have NC bar plus MC bar, okay, equals to MB bar plus NA bar. So C bar I take common. So here I get M bar, I'm sorry, M plus N. Those are numbers. And here you have MB bar plus NA bar upon M plus N. So what is C bar equal to? C bar equals to MB bar plus NA bar upon M plus N. Upon M plus N. Okay. So this is the theorem. This is the theorem. We got the position vector of point C. What I had point C dividing segment AB internally in the ratio m is to n. I could express the position vector of point C. I could express the position vector of point C in terms of position vector of A and B. Now from here I can take the discussion ahead. But before I do that, one more thing. See, in some of the books, instead of point C, in some of the books, you will notice that instead of point C, they write point R. So if point R, then this would be R bar. So small change. And this will be, see, you write point C as R. So it is AR upon BR and all such stuffs. I hope you are big enough to understand this small changes. Okay. So students, we have done this. Now see, as I told you that we would also be going for the coordinates. Okay. We would also be going for the coordinates. So that also I will do. But before that, I want to make one more thing very clear. Okay. So let me first make that thing clear. See, here I wrote AC upon BC as M upon N. Remember, here AC upon BC as M upon N. Now in this equation, everything is number. Everything is number. And here also, everything is number. But the vector started coming from here. And since the vector started coming from here, you had to make choices for their direction. You had to take account of their direction. Okay. So now think, if this had been written the other way, please, okay, check this out. If this had been written in some other way, what I mean by some other way, I'll let you know this. See, AC upon BC as M upon N, I could have written this as, I could have written this as CA upon BC as M upon N. Okay. Can I write AC upon BC as CA upon BC? Why not? Because they are numbers. AC and CA are equal so far as they are numbers. They are numbers. If they are vectors, then they are not equal. But here we are writing numbers. Now I cross multiply. So here I have NCA equals to MBC. I cross multiply. And then what I do is, now I change this to vectors. So see here, NCA bar. Okay, and here I have MBC bar. What I have NCA bar. Okay, let me use smaller pen, a thin pen, so that I can accommodate. So NCA bar, okay, equals to M, and here I have, okay, let me first not write equal to. So see here I'm changing it to vector. So NCA bar, and here it is MBC bar. Now let me think. CA bar. Look at the direction of CA bar. In the diagram, look at the direction of CA bar. CA bar is this direction. And BC bar. Look at the direction of CA bar. It is C to A. This is the direction. And B to C. Look at the direction of BC bar. It is, so see, this time the direction is same. So what I want to say is, this time you can write equal to without changing the sign. You can write equal to without, you don't have to write negative. Don't have to write negative the way you wrote here. Okay, here writing negative was mandatory because the direction was different. So if you are writing this way and you are solving, then you will go without writing negative, and you will still get the same thing. You will still get the same thing as we got here. You will still get C bar as this. You will still get C bar as this. You can try it doing it. You can try doing this. What you will have to do next, you will write N A bar minus C bar. AC bar. What is AC bar? A bar minus C bar equals to M C bar minus B bar, and then you multiply it inside, and then you take the C bar at one side and do it. You will get the same thing. So what I'm trying to say is, when you are at this step, you need not worry. Only when you come at this step, when you are converting it to vectors, give this a thought, whether the directions of those vectors are same or they are opposite. If the directions are same, don't have to put a negative sign. If the directions are opposite, then you will have to put a negative sign. I hope you followed this. This completes the first part of internal division section formula. Now let us take this discussion ahead. What I will do here is, see, we have the coordinates of these points. I mean the coordinates of point A, B, and C. I will write the position vector of these points. I will write the position vector of these points. So if I know if point A is x1, y1, z1, so A bar, okay, A bar will become x1 I cap plus y1 j cap plus z1 k cap. A bar will become this. B bar will be x2 I cap plus y2 j cap plus z2 k cap, and C bar will be x I cap plus y j cap plus z k cap. C bar will be this. Now these I substitute in this formula. So I will write, using A bar, B bar, and C bar in one, we get, I write here, using A bar, B bar and C bar in one, we get, see what we will get. We will get C bar equals to, I will get here, C bar equals to, what was it? It was MB bar. You remember? It was MB bar plus NA bar. So MB bar X2 I cap plus Y2 J cap plus Z2 K cap MB bar plus NA bar, that is N, X1 I cap plus Y1 J cap plus Z1 K cap upon M plus N, upon M plus N. Okay, what I did, MB bar, I substituted B bar, and NA bar, I substituted A bar. Okay, so having done this, I'm getting it like this. So the next step I will get is, okay, I did not substitute for C bar, that I will do at last. Okay, C bar, you remember what is C bar? C bar is this. C bar is this. Okay, that I will do at last. I will do that at last. So here I have C bar equals to, now I multiply this M inside in all the three terms inside the bracket. So I will get here mx2, see, I will get here mx2 I cap, okay, plus my2 j cap plus mz2 k cap, and the same thing I will do with n. So that will get me nx1 I cap plus ny1 j cap plus nz1 k cap upon m plus n. In the next step, check this out. mx2 I cap, you got here mx2 I cap, okay, and here you have nx1 I cap. So we can take I cap common from these two, right? We can take I cap common from these two. So I will get C bar equals to, I will get here mx2 plus nx1 times I cap, and the next one I will get, I will take j cap common from these two, j cap common from my2 j cap and ny1 j cap. So my2 j, I'm sorry, I'm taking the common. So my2 plus ny1 times j cap, and finally mz2 plus nz1 k cap upon m plus n, upon m plus n. So the next one I will get is, now see, I will divide, there are three terms in the numerator. I shall divide each one of them separately by m plus n. Okay, there are three terms with a plus sign, separated by plus sign. So I will divide by each term separately. So see, what do I get? I get here next step as, therefore C bar, now this time I write C bar, it is xi cap plus yj cap plus zk cap equals to, now separately divide on the RHS, mx2 plus nx1, I cap divided by m plus n. You see this? Plus, now look at the next one, my2 plus ny1 j cap divided by m plus n, and finally mz2 plus nz1 k cap divided by m plus n. Okay, so now what? Now we will, since we have both the sides equal, see, this vector is equal to this vector, so now we can equate the coefficients. So the coefficient of I cap here is x, and here I cap coefficient is this. Okay, then the coefficient of j cap is y, and here it is this, and the coefficient of k cap here is z, and on the right side it is this. So what I will get next, therefore, see, I'll get here Therefore, x equals to mx2 plus nx1 upon m plus n. Y equals to my2 plus ny1 upon m plus n. And z equals to mz2 plus nz1 upon m plus n. See, you got the coordinates of point C. You got the coordinates of point C, that is x, y, z. You got the coordinates of, you got all the coordinates of point C. And what is it? See, x is mx2 plus nx1 upon m plus n. Is it not the same as what we had done for 2D? Yes. There also the x coordinate was, this only, and y was this only. The only thing, we did not have the z coordinate there because that was in 2D plane, that was in two-dimensional plane. And here we have to take care of the z coordinate. So what is C finally? Okay, C is, you will write the coordinates of C. C, the x coordinate is mx2 plus nx1 upon m plus n, and y coordinate is my2 plus ny1 upon m plus n. Z coordinate is mz2 plus nz1 upon m plus n. Okay, so only this part is addition to the concept, else everything was same as what we had done. So students, I will stop here. You can revise the whole video once again. You can check this, you can copy this, write it 2 times, and also try to learn it well. Okay, I will stop this video here because this is becoming a quite lengthy video. The remaining part, that is midpoint formula, centroid formula, tetrahedron formula, and external division section formula, I shall be taking in the next video. Thank you.